Hello everyone. In this video, I'll discuss about minors and cofactors of a determinant. Minor of an element aij of a determinant is the determinant obtained by deleting its ith row and jth column in which aij lies, and it is denoted by mij, that is, to find minor of an element aij, you have to delete ith row and jth column. Why ith row and jth column? Because aij is an element lying in ith row and jth column. The determinant obtained by deleting ith row and jth column is the minor of aij, which is denoted by capital Mij. So if you find the minor of an element whose determinant is of order n, where n is greater than or equal to 2, then the minor will be determinant of order n minus 1. So we'll consider an example. So here determinant of order 3 is given. So you are asked to find minor of element 6 in this. Minor of element 6. So 6 lies in second row, third column. So to find the minor of element 6, we have to delete second row, third column. When you delete second row, third column, we will get a determinant of order 2. That is, we will get the determinant 1, 2, 7, 8. So if you find the value of this determinant, it will be 8 minus 14. So that is minus 6. So minor of element 6 is equal to minus 6. So one more, if suppose you want to find minor of 1, so you delete first row, first column. So you'll get the determinant 5, 6, 8, 9. So that is determinant 5, 6, 8, 9. So that is 45 minus 48. So the value is minus 3. Now next we'll define cofactor. Cofactor of an element aij denoted by capital Aij is defined as minus 1 to the power I plus j mij, where mij is minor of aij, that is giving proper sign to the minor according to the position of the element. So that means cofactor is giving a proper sign, that is, or in other words, multiplying the minor with plus 1 or minus 1 depending on the position of the given element. For example, cofactor of element 6 in the same exam, same determinant, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. The minor we got it as minus 6, but 6 lies in second row, third column. So if you add both, it will become 2 plus 3, that means it will become minus 1. So minor is minus 6 multiplied with minus 1 because the position is second row, third column. So it will become minus 1 into minus 6. So it will become 6. So this is the cofactor of element 6. So depending on the position, we have to multiply the minor with either plus 1 or minus 1 to get the cofactor. So in the same example, we have found minor of 1, that is m11 equal to minus 3. It is 45 minus 48, so it is minus 3. Since it is m11, it's 1 plus 1 is even, cofactor is also same as minor. So cofactor is also here minus 3. So cofactor of minor of 1 is, that is the first element, minor of 1 is minus 3. Cofactor of 1 is also minus 3 because it is in first row, first column. So it needs to be multiplied with plus 1. Now let us find the cofactor of elements of first row, that is A11, A12, A13. In the determinant delta is given A11, A12, A13, A21, A22, A23, A31, A32, A33. So we'll find out the cofactor of first element, that is A11. So what you need to do is delete, that is first row, first column. So first row, first column is deleted. The determinant is A22, A23, A32, A33. Now you have to multiply with the position. This is the minor, and you multiply with the position, that is minus 1 to the power 1 plus 1. So it is minus 1 square, so it will remain as it is. So it will be A22, A33 minus A32, A23. Now cofactor of A12, that is first row, second column. So it will be minus 1 to the power 1 plus 2. Then delete first row, second column, the remaining determinant A21, A23, A31, A32. Because it is in first row, second column, this sum is negative number, so there will be a negative sign here. You expand the determinant A21, A33 minus A31, A23, then negative of that, so it will be A31, A23 minus A21, A33. Now similarly, find the cofactor of element A13, that is first row, third column. It is minus 1 to the power 1 plus 3. Delete first row, third column. So A21, A22, A31, A32. So if you expand this determinant, you will get A21, A32 minus A31, A22. So these three are the cofactors of elements of first row. Now this is determinant is delta. Now let us expand this determinant along first row. So first row, that is minus 1 to the power 1 plus 1, A11, delete first row and first column, the remaining determinant, plus minus 1, 1 plus 2, A12, determinant A21, A23, A31, A33, minus 1, 1 plus 3, A13, determinant A21, A22, A31, A32. That means to find the value of the determinant using first row. We already discussed this, how to expand along first row. Now if we observe that this minus 1 to the power 1 plus 1 and this determinant is same as A11, that is the cofactor of the element A11. So similarly, this determinant is same as A12 and A13, that is cofactors of elements of first row. So that means if you multiply the elements of first row with their corresponding cofactors, so you take the elements of first row and multiply with their corresponding cofactors, we'll get the value of the determinant. So to find the value of the determinant, this is applicable to any row or any column. You find out the sum of the product of elements of any row or column. You take any row or any column and multiply with their corresponding cofactors, so that will be the value of the determinant. So it can be easily verified for other rows and columns. Here it is verified for the first row. So we have taken first row, multiplied with its cofactor, we got the value of the determinant. The same can be used for any other row or any other column. So if we multiply elements of a row or column with their corresponding cofactors, we will be getting the value of the determinants. Suppose if the elements of a row or column are multiplied with cofactors of any other row or column. So instead of their corresponding cofactors, if elements of a row are multiplied with cofactors of any other row, then their sum is 0. So that means if you take the cofactors of first row, we already found this for the same determinant A22, A33 minus A32, A23. So A12 also we found A31, A23 minus A21, A33, A13, A21, A32 minus A31, A22. So these are cofactors of first row, cofactors of first row a11, a12, a13. Now suppose if we multiply the cofactors of first row with elements, corresponding elements of second row, a21, a11, a22, a12, a23, a13, then sum of products of those will be equal to 0. So that means if elements of a row are multiplied with cofactors of any other row, then their sum is 0. Similarly, elements of a column multiply with cofactors of any other column, then their sum is 0. So if you multiply with the cofactors of same row, you will get the value of the determinant. If you multiply with cofactors of any other row, then you will be getting the sum as 0. Okay, now let us see via example of these two remarks. So first here, using cofactors of elements of second row, evaluate the determinant. So this is the determinant. So you are asked to evaluate using cofactors of elements of second row. So first you have to find the cofactors of elements of second row, that are 2, 0, 1. So cofactor of 2. 2 lies in second row, first column, so that means you have to multiply with minus 1 to the power 2 plus 1. So remove second row, first column, so you'll get the determinant 3823. 3823, that is the determinant. So if you evaluate this determinant, it will be 9 minus 16, so it is minus 7, and this is minus 1 to the power 3, so it will become minus of minus 7, so it will be plus 7. Now cofactor of the second element of second row, it is 0, so minus 1, it is a22, so minus 1 to the power 2 plus 2. Determinant obtained by deleting second row, second column, so it is 5813, so it will become determinant 5813, that is 15 minus 8, so it's equal to 7. So there is no change in the sign because it is minus 1 to the power 4, that is a positive number, so this is multiplied with plus 1. Now similarly, the cofactor of the third element, so that is 1 here, so cofactor of 1, it is in second row, third column, so multiply with minus 1 to the power 2 plus 3. So delete second row, third column, the determinant 5312, so that means 10 minus 3. So it will be 7, but because it is minus 1 is here, so it will become minus 7. So the cofactors of 2, 0, 1 are 7, 7, minus 7. Now you have to get the value of the determinant, you have to multiply the cofactor with the corresponding elements. So that means 2, the cofactor of 2 is 7, so 2 multiplied with 7. Cofactor of 0 is 7, so 0 multiplied with 7. Then cofactor of 1 is minus 7, so 1 multiplied with minus 7. Then sum of this, that is 14 minus 7, so the value of the determinant is 7. Similarly, if you take any row or any column and multiply with their corresponding cofactors and take the sum of the product of those, then you will be always getting the value of the determinant. So if you, this is another compact way of finding the value of the determinant, that is multiply each element of a row with the corresponding cofactor and take the sum. Now the second remark, here we are taking elements of second row and multiplying with the cofactors of first row. So in the second remark, if you multiply the elements of any row with the cofactors of any other row, then the sum of the values, sum of the product will be 0. So here we are taking cofactors of elements of first row. So cofactors of elements of first row are 1, 0, 4. Now we are taking the cofactors of elements of first row, so cofactor of 1, that is a11, so minus 1 to the power 1 plus 1, we delete first row, first column, so it will be determinant 5 minus 1, 2, 1, so it will be 5 minus of minus 2, that is 7, here it is positive, minus 1 square, so it will be same as the value of the determinant, that is 7. Now cofactor of 0, 0 is in a12, so first row, second column, so minus 1 to the power 1 plus 2. So minus 1 to the power 1 plus 2, so you delete first row, second column, so determinant 3 minus 1, 0, 1. And it's equal to 3, value of the determinant is 3, but here it is minus 1 is there, so the cofactor value will be minus 3. And cofactor of 4 is a13, that is first row, third column, so it is minus 1 to the power 1 plus 3, delete first row, third column, so 3, 5, 0, 2, so it will be 6, here it is positive, so there won't be any change, same as the value of the determinant. Now what we are doing here, we are multiplying elements of second row, that is 3, 5, minus 1 with cofactors of first row. So a21, a11, a22, a12, a23, a13. So here 3 is multiplied with cofactor of 1, that is the first element, the corresponding, so 3 into 7 plus 5 is multiplied with cofactor of the second element, that is minus 3, so 5 into minus 3. Then minus 1, the third element here, is multiplied with cofactor of third element of first row, so that is minus 1 into 6, so it will become 21 minus 15 minus 6, that is 21 minus 21, it will come as 0. So if I multiply elements of third row with cofactors of first row, then also I will be getting it as 0. So here third row elements are 0, 2, 1, and the cofactors are 7 minus 3, 6. So 0 into 7, 2 into minus 3 plus 1 into 6. Then also you'll get minus 6 plus 6. It's equal to 0. So if you multiply elements of any row with cofactors of any other row, and sum of those will be equal to 0. But if you multiply elements of any row with their corresponding cofactors, that will give you the value of the determinant. That's all in this video. So I will be continuing with this chapter in the next video.